Hey folks, today we're going to talk about a fidget spinner. This is a 3D printed fidget spinner that I designed in Onshape and then used a couple of real world parts instead of just 3D printing to go ahead and make it a thing. Let's talk about it. As far as materials go for this project, you're going to need like 5 things. You need an internet connected device, hopefully a computer that you can use Onshape on, or your modeling software of choice. That's one. Second one, you need a 3D printer in order to do the 3D printing parts of it. Third one, you need filament to actually go through and print. Then you need bearings, or just a bearing for the spinning part of it. And then you need some type of weight. I like to use hex nuts for it, and I'll go over the whole list of materials here in just a moment. But that's all you need. It's super quick, super easy, and super cheap to make tons of these things very easily. So the bearings come in tubes like this. They're not a big deal. They usually come in sets of 10, and usually I buy a whole box of them. So I get between I think it's 50 bearings at a time for like 20 bucks, if that. It's not very expensive. These are really terrible bearings. They're not very good. I'll link them down below. It's not going to be an affiliate link or anything like that. So buy away, and I don't get anything from it. I don't need it. But they come in these little tubes. So you take them out, and that's going to be the main thing that you have for the spinning part. Then, because the spinning needs to have some weight or momentum, object in motion wants to stay in motion, we need to have some weight with that. And that's where I use these. These are like 10 bucks. It comes in a set of 100, and they are great. They're very inexpensive, they fit, and they're very consistent in size, which is the important part. The bearings and also the hex nuts are both very, very consistent in size so that we can reliably print at a certain size and we know that it's going to fit. Because 3D prints are always going to be the same, more or less, but we have to make sure that the materials we're putting into them are also going to be the same. And then once you go through and print all the things out, you get something like this. You notice that it's gray here. Underneath this is actually the bearing. I made some little thumb screws I'll show you in a second, and did some different sizing things to make sure all of this works, but it works and works really well. Let's jump into Onshape and see how it works. So what we went ahead and did here was we have 3 different size rings. They're all very similar in size. They're only 1/100 of an inch really difference between the largest one and the smallest one. But that does matter because we're going to be press fitting the bearings into this. So I want to make sure that it fits exactly what we need. So I took a dial caliper, measured up the bearings, got a rough average over a couple of bearings. They don't really deviate much. But I want to make also sure that we accounted for the difference in sizing for the 3D printer, because there is a little bit of different sizes from what you design to what actually prints. So I made these 3 rings, and I found out that the 0.68 diameter hole here perfectly accepted the bearing without a lot of effort and kept it held in there. So that was the main thing that we had for that. And then I also developed these thumb screws. This one has a matching diameter. It's a little smaller actually, but a matching diameter and a hole, which then the second thumb screw goes in. And these cover the top and the bottom so that we cover the bearing entirely. We don't get any grease or oil or anything else on there, and it allows it to spin significantly better than what it does otherwise. Because I use really cheap bearings for this project because it's a fidget spinner. It doesn't need great quality bearings. Okay, now that we have our sizing, we've printed our test pieces to make sure everything works, we're going to go through and actually design our fidget spinner. It's nothing too big of a deal. We're going to start off on the top view, I believe. Doesn't really matter where we're at. And we're going to start our circle off with the size of the bearing, which we determined was 0.68 is what fits our bearing. After we do that, we're going to have some type of ring that's going to be separated around. This area is going to be hollow for obviously the fidget to be able to have the bearing. And then we need something to support all of that kind of as the main body. So I'm going to dimension between the two, and I guess we're going to go with about 1/4 of an inch just to get set up with. We have several options of what we can do here now. We could draw out the legs and then do a circular pattern around. We could draw a maximum size where we take a measurement of our hand and just figure out what rough size can we do. Just a heads up, adult hands and even like teenager hands, roughly about 4 inches in total diameter. So you're holding about 2 inches there, we'll be fine. So what I think I'm going to do here is draw this out, and we'll make that 4 inches. So it's from the center out to the side, or also known as a radius. It's going to be 2 inches, and 4 inches all the way across. So my thumb here, if it's on the origin, is going to be able to hold that little area. That's all we have to clear, and I think we'll be fine. After that, we can just kind of go through and do whatever we really want to do. I'm going to throw some lines in here, just vertical lines going up. We can make them fancy if we want. We can put splines and all kinds of stuff. I don't really care about that. I just want it to be there. And then we hit E for equal. We're going to put an equal constraint so that they're on the same size there. And what that does is allows them to be centered. So if we move them out, you can see that they stay equal and they're also centered along that vertical line, even though it's not a line. It's really just a plane. I am going to add a dimension between them just so that I have a little bit more to go with. I think 0.75 is going to be good, especially because of the size of the hex that we're going to need for the weights. Now, What I want to do at this point is I want to go over into a circular pattern, which will go up here where a linear pattern's at. We'll click that drop down and go to circular pattern. And all I need to do is select these two guys right here. And you can see that it will do all the stuff. And then if we zoom in here, you can see that 3x, if I wanted more legs or arms or whatever you want to call them, we can do it. I'm just going to stick with like a very basic, simple fidget spinner where it's 3, hit enter, and there we go. We have that in there. And then we use the trim tool or with the letter M, we'll go in and trim out the things that we don't need just so that we have everything kind of known on here like so. So that's the main body and design of our fidget spinner. We'll finish our sketch and we're going to extrude just the body, not the circle in the middle. And we're going to do it about 1/4 of an inch or so, maybe even 0.2. It doesn't really matter as long as it's not so thick that the bearing is swallowed up by it. And we'll be fine with that. So I'll hit my green check at this point, and that's all well and good. I still need to do some more work, so I'm going to sketch back on top of here. And I suppose I could have done this originally, but I didn't want to. I like doing this in stages just because mentally I want to get the hole and the arm set up, and then I can worry about the holes for the hex nuts, and then I can also worry about any decorations or anything. So that's kind of where my brain is at on that. So I've selected the polygon tool. I'll click on somewhere here. It doesn't really matter right now. I'll go out and try to get that lined up like so. And it should be default 6. If it's not, you can move your mouse up or down. I believe the highest number it goes to is 50, and it's just the number of sides. You're not stuck into this, so if you misclick something, you don't have to do it, but it does make it a little easier to do that. But you can see I can just double click on that number, and if I change it to 8, that thing's automatically going to update to whatever number I put in there. Now, I do want to set some dimensions, particularly how far this is from the center. If we take a look at that, I'm going to make that probably 1 3/8 inches. So there's a little meat at the end that we can decorate that if we want to. And then the more important thing is here is we zoom in between the flats. So one parallel line to the other like parallel line, or as it's called in the manufacturing stuff, between the flats of the hex. It needs to be a very particular size. So we're going to dimension between those. And again, you might have to run some tests to see what fits with your hardware. But we're just going with inexpensive, easy to get stuff. And that's what we got. So it's 0.43, and we're going to cut that hole out. But before we do that, we need to do a circular pattern just like we did before. So we'll select all the edges of this bad boy. And while it's hard to see, they are there and they are there. There's 3 of them. Fantastic. We'll just click off to the side. We have them there. They're going to be blue because they're not fully defined. But what's cool about this is if I change some of the parts of this, like let's say I change this guy here to 0.5, these both grow as well. So they retain the properties of the original. It's just that they're not locked into place by black lines because they're not fully defined as far as the program is concerned. I'll finish my sketch and then I'll extrude 1, 2, and 3. We're going to remove, and I don't really care about distance. We're just going to go through all, making sure the arrow is going the right way. We can see it's going back through. If it gives you something like this, just click that black arrow for opposite direction and it'll remove it, no problem. So I'll hit my green check there, and I'm happy with that. There are some other things I want to do, I think. So I'm going to put some fillets in on these areas here. So I'm going to get all of these, and I'm just going to play with numbers. I don't really know what the number is going to be quite yet, but I want to do something that kind of pops in. So 1/2 inch, no. Maybe 1 inch, no. 2 inches. It's getting better. 3 inches. About 5. All right, let's do that for right now. Can I do any larger? 6. Basically, what we're looking for is that they stay orange. If they turn pink or purple kind of color, or stuff just disappears where you don't see the visuals, it means it's not going to work. So I'll add that fillet on there, and then we're going to fillet it again because those two, not that one. We want to get the center line here. Ooh, okay, it's giving us an error because the radius is too large. All right, that's what we need. We just need to change that. But sometimes if you select the whole surface, it's also going to freak out. But I have the 3 there, and we'll round those over. There we go. I'm also going to go in and fill it off the ends of these guys. It's going to give me an error message, so I'm going to do 0.375 is the radius because we know that this is 3/4 of an inch across, and if we take 3/4 divided by 2, we get 0.375, or 3/4 divided by 2 is going to be 3/8. So I have that there. We'll check mark that. And then the last thing, and probably one of the more important things to do with as far as being able to assemble and build this thing, but also going through and getting it comfortable to feel, because the edges on these can be kind of sharp, even though it's all rounded. We still have 90-degree transitions between the like the top and the right side. We want to round these over a little bit. It's also really going to make getting the bearings and the weights in there much, much easier. So we're just going to do entire surfaces. I'm going to click on the entire front, and I'm going to click on the entire back. And you can see that there's error messages all over the place because this number is too big. We're gonna play and see what it do. I like 0.05. I think that's a good size. It's not so much that it kind of looks weird, but it's comfortable to hold at that size. You can play with it whatever you want. You just can't. There has to be a flat enough area in here and in here to hold the bearing and to hold the hex nuts. If there's too much round in there, like if I were to put that at, let's say, 0.125, you see it rounds it all the way over, and there's nowhere for it to really grab on those things. So I'm going to keep it relatively small so we have a larger surface and contact area to get that to work. And then that's that. So our next step is to go and export this thing, throw it onto the printer, and see what we have. So now that we've exported this thing, we're pretty much ready to go. If you want to, you can add some more strength to it. I don't think that's really necessary, but knock your socks off if you want to. Just increase those wall loops, and we'll make it stronger. I don't think it's necessary to go beyond 2 for this, and I use 10 to 15% infill. Doesn't really matter, but that's what I want. And I'm just going to have that as is. So we're going to go over to preview this out. It's going to take 24 minutes and 11 seconds to actually print, and setup time is 5 minutes. So it's under a half hour, so you can pump these out pretty quick, and I could put more of these on the build plate if I need it. I think I could get up to 6 of them if I rotated them and kind of nested them together. But I don't need to do that. This one's just fine. So we're going to print the plate. We'll get that in, let's say, orange, and then we'll send that over to the printer, and let's turn on time lapse. Why not? We'll send that over, and we'll see what the print result is here in just a little bit. All right, so here's the finished print. It came out really nice. I love the texture side. Textured stuff makes me happy. The other side looks fine, but I love the textured look of this stuff. So what we're gonna do now is we're gonna take the bearing, we're gonna place it into this, which it should just press fit in, no problem. Again, it's not, you have to take some force to get it out, but it's nothing crazy or wild in there. And it does spin a little bit. You can see it's kind of going. These are not high quality bearings. What really does the spinning is the caps. So basically this one right here, we're going to put that in first, like so, boop. And then we put a little dab of super glue, and then we'll take the top cap and just stick it on there right there. And then it spins much better, like way better. It's not a big deal. But to get it spin even better, we're going to take what we call the weights and put them into the hex holes, and we'll be ready to go. So give me a second to get the box open because this is a brand new box, and then I'll push them in there and we'll go from there. All right, and basically all you do here is take the nut, line it up so it goes in there, and just kind of force it in. The 0.43 that we have as the dimension for that, it's tight, but it allows you to push it in, and it doesn't require any real thing to hold it in there, which is awesome. The caps, on the other hand, do definitely require super glue to stay on, but the nuts should stay in there without any problems. I'll get the other ones in there, and I'll show you how it spins. All right, so they're all in there. You can see it's set in there, and then all we're going to do is spin it. And again, this is a really cheap bearing in there. So as a final note on what we have here, material-wise, we have 3 hex nuts in this. The box is really inexpensive. We have 1 bearing, and then we have like 4 cents worth of plastic, and we get a wonderful thing out of it. I'm really happy with how it turned out. I love being able to do this, and I love that students can go through and design whatever they want. As long as this thing is able to fit within the hand area there and spin, we're good to go. And then obviously limit so that there's no sharp edges, no weapon looking things, all that. We'll put all that stuff in there, but we want to make sure that all that's set. So that's my 3D printed fidget spinner project that I love to do with my students, and hopefully they enjoy as well. So if you have questions on how to do something like this, let me know. I tried to show you all the steps that I went through when I started working on this project and developed parts of it, but I'm really happy with how this came out, and I really love having fidget spinners available whenever I want them. They're just a half hour away. Until next time, folks, I'll see you later. Bye-bye.